Hi, my name is Lisber Pontes. I'm a senior principal software engineer at Milestone Systems. And in this presentation, I'm going to talk about the installing, configuring, and running Milestone AI Bridge. This is the agenda for this presentation. Let's start now by talking about the hardware and software requirements behind Milestone AI Bridge. In terms of hardware, Milestone AI Bridge has no requirements per se, as it acts mainly as a gateway between the VMS and the IVA applications. Thus, the real hardware requirement will be defined by the running IVA applications within the cluster. Most of the time, these IVA applications will require GPU cards and a considerable amount of RAM. In terms of software, Milestone AI Bridge is composed of several Linux-based OCI images, and thus a Linux host is needed. We have been testing, and thus we recommend running Milestone AI Bridge on Ubuntu distros. However, this is not a hard requirement. For Kubernetes-based installations, Milestone AI Bridge will require a running Kubernetes single or multi-cluster ready before installation. Let's review now how to download Milestone AI Bridge. As it has been mentioned before, Milestone AI Bridge comes as a set of OCI images and also as a Helm chart package for easy installs on Kubernetes setups. All of these artifacts are publicly available on AWS ECR public repository. So when you access to this URL, you will land into the Milestone AI Bridge official page on public ECR. From here, you will be able to find a small introduction to what is Milestone AI Bridge, access our EULA file. From the usage tab, you will find direct links to our portal documentation, as well as direct links to the Milestone download page. And last but not least, you will find some artifacts that we have been deploying, such as the Helm chart package and also all of the OCI images. Another important aspect to take into account when downloading Milestone AI Bridge are a set of resources that we have deployed on the Milestone download page. So the first action that you need to do in order to install AI Bridge is to go to the Milestone download page, filter for AI Bridge product, and download the Milestone AI Bridge resources. Here is a direct link for these filters to be pre-selected, but whenever you come into the Milestone download page and you filter for the AI Bridge, and you will find a link to these AI Bridge resources. Once you download these AI Bridge resources, you will have this zip file. So when we unzip it, you will see all of these folders within the zip. It's worth to be mentioned that there is a README file that showcases or explains what's inside of each of these folders. So let's just go quickly through them. So the first one is the compose deployment. In this folder, you will find all of the files that are needed for a quick deployment of AI Bridge on a Docker composed installation. Then we have the reference manual. This is the GraphQL API definition that any developer or IVA application developer should use in order to explore the AI Bridge API on an offline manner. Then we have the AI Bridge XProtect patch. In this folder, you might find files that are needed on older versions of XProtect in order to work properly with AI Bridge. Also, you will find an AI Bridge XProtect plugin. This is the management client plugin that should be installed on every single management client application that needs to deal or work with AI Bridge. All right, let's now install Milestone AI Bridge. First of all, in order to install Milestone AI Bridge, we should download the Milestone AI Bridge resources from the Milestone download page, as it was shown in the previous section of this presentation. That zip will include one of the components that is required for the installation. This AI Bridge as a product is made of two components, one client side and one server side. For the client side component that must be installed is this management client plugin. This management client plugin, it's part of the resources zip file that we download from the download page. And it's basically needed on all management client applications that require to manage an AI Bridge installation. As part of the installer of this plugin, WebView 2 will be checked if it's installed or not, because it is a requirement on this plugin. If it's not installed, the management client plugin will inform the user and wait until this WebView 2 gets installed so that it can finish the installation of the plugin. On the other hand, we also have the server-side component, which is the Milestone AI Bridge engine. We offer two types of packages for installing the AI Bridge server-side. One option is through a Docker Compose configuration files. As mentioned before, this is advisable for a small size installation or less intensive video analytic application processing. And we also offer a Helm chart package for the Kubernetes installations of AI Bridge. And this is the right decision or the right environment for more intensive video analytic processing applications. Also allows to scale up out of the box. So now let's have a look into how to install the client side. First of all, after you download this zip file, the resources from the Milestone download page, what I'm going to do is to copy this installer to the location in which the management client that I want to use is sitting on. So in this case, in this machine. So let's see how is the installer process. We will need to accept a EULA. And that's basically everything, because I already have WebView 2 installed in this machine. There was no extra step asking us or me to install the WebView 2 plugin. If it was, then we will see it during the installation. Once we install this plugin, we can confirm and we can see a different behavior in the management client. So let's take a look at it. We will see in the left side panel a new icon called processing servers, as this one. And we will also see in the cameras, if you filter for a camera and you select a camera, you will see this processing server tab. This is part of the plugin. And we are going to delve into it in the future sections of this presentation. So now let's look at the server-side components. All right, let's now install Milestone AI Bridge based on a Docker Compose installation. I would like to stress that all of the steps that you're going to see in this presentation can be found in our Milestone official documentation portal for AI Bridge. So if you click on Create Processing Server and you browse the deployment using Docker Compose, you will find all the steps that are needed to install AI Bridge on a, let's say, Docker composed environment. But obviously, as part of this presentation, we are also going to do it here. First of all, when you install Milestone AI Bridge on a Docker Compose installation and also on Kubernetes, you need to create or have at your disposal a basic user in Milestone XProtect. This is going to be the user that AI Bridge will use when communicated or interacting with the VMS. So let's go and create this basic user. So we go here and I will create a user called demo user with a super strong password as the one that you can see on the display. And I will not want this to be changed. And as it is in version 2.0, the user that is going to be used by the AI Bridge needs to be part of the admin role in Milestone XProtect. This is a behavior that we plan to change in the next version of AI Bridge, but in 2.0, the AI Bridge user that it's or the XProtect user that it's used by AI Bridge needs to be part of the admin role. All right, now that we have a Milestone basic user created, the next step is to inform about this user prior to the AI Bridge installation. Since we are using, in this case, a Docker Compose installation, let's go back to the zip file that we downloaded from the Milestone download page. And then inside the zip file, there is this folder called AI Bridge Compose Deployment, and then a subfolder with AWS. Within that folder, we will find this file, the environment variable file. Let's open this file. Before modifying this file, I would like to stress that all the definition on every single property in this file can be found in our official documentation page. So please go and refer that for further explanation. So the first thing that I am going to do now is to inform about the management server address. It is important to mention that depending on whether you're running your VMS secured or unsecured, meaning HTTPS or HTTP, you need to inform this when filling this file for the AI Bridge to connect properly. So the first thing I'm going to do is to inform the management server hostname. In my case, this management server is hosted at this address. It is part of my active directory, so I'll be using a fully qualified domain name for my VMS. Then the user and password that we defined before. So we define a user called demo user, and if I don't recall badly, the password was demo at 12345. Then the last thing that we should touch in this file is providing the information on where is located the VM, the Linux VM or the Linux host that it's going to run the AI Bridge. In my case, my Linux box is at this address, and it has this host name defined. All right, so now we save this file. Once we have the environment file filled with all the required information, we are good to go on moving forward with the Docker Compose installation. However, there are something that I would like to mention as part of the video tutorial, which is the fact that inside the AI Bridge Compose deployment folder, there are two compose files that could be used. One called Docker Compose YAML, and the other one called Docker Compose Production YAML. The reason why we have deployed these two files within the Compose deployment folder is that if you are an IVA application developer, you might want to start deploying the AI Bridge with this file, because this is what we call the AI Bridge running in debug mode. And the meaning is that if you deploy AI Bridge pointing or using this file, then the AI bridge will be exposing all of the ports outside of the network or of the composed network. And that might be useful in case you are developing an application that it's running on a different host and you want to interact with AI bridge. To exemplify this idea, I would like to show a small diagram on how this is or how this can be perceived. So when you run the Docker Compose file, what it will happen is that since the AI bridge will expose all of the ports to the outside of the Compose network, then an IVA application sitting on a different host could start consuming and communicating with the AI bridge. However, as it has been mentioned in the past, what a production environment must do is to run the IVA application within the same network of the AI bridge. So if you use the compose.yaml, this is the outcome, that every single component on AI bridge will be accessible from the outside of the compose network. Whereas if you use the Docker Compose production file, which is what we advocate when installing AI bridge on a production environment, what will happen is that not a single port will be exposed out of the Compose network. And that means that only the IVA application running within the same Compose network is going to be able to access the AI bridge endpoints. So from a security perspective, this is what we encourage every single production application to run against. Now that we have seen the usage of the two Compose files, we are ready to start deploying AI bridge on a Docker Compose installation. For that matter, I would like to mention or reinforce this idea on the AI bridge Compose deployment folder that has AWS subfolder, because this is exactly all that we need to deploy the AI bridge on a composed installation. Remember that we have already set and prepared the environment file so that it points to the right VMS with the right credentials, and it also has the information in regards of where is this Linux box located. So in order to copy these files from my Windows environment into my Linux host, I'm going to use a tool called SCP, which stands for Secure Copy Protocol. This is a tool or a command line utility tool that allows to move files between hosts. So I'll be basically moving from my AWS folder on Windows into a specific location in my Linux box. So I'll be using PowerShell, and as you can see from here, I'm sitting on the AWS subfolder because this is exactly the folder that has all the files that I need to copy. Also, it's important to mention that any file with the dot in Windows might be perceived as a hidden file. So we will need to inform the SCP that we also want to copy this file as well. So let's start to copy this content. So we use the SCP command line utilities. We include the -R to recursively copy folders or subfolders under content. Then we say asterisk to copy everything. And then because we also want to copy the .env, we should be explicit by saying .asterisk. And then the hidden files will be copied as well when calling the scp command. The next step is to inform which is the Linux user that should be used when copying this command. It happens that in my Linux box, I have a user called user. And now I need to inform about the location of my Linux host, which is sitting at this location. Last but not least, I need to inform about the path in this host. So in my Linux box, I created already a folder called demo. And this is exactly where I'm going to copy all of the files that are sitting in the AWS folder. So once we run this command, we are going to be prompted to type the password of the user on Linux. And now we can see from here that all of the content has been copied into the Linux box. Now that we have copied all of the files to the Linux host, we can install AI Bridge using Docker Compose. Let's see how to do it. Before showcasing those steps, I want to stress and reinforce that all of the steps that I'm going to show in this video tutorial are fully explained in our official documentation. So for instance, all these commands that I'm highlighting, they are going to be used by me now, and they are fully explained in our official documentation. So just bear in mind to use or to refer to that documentation when needed. So how I'm going to do it is that I'm going to connect to my Linux host, the one that we have copied the files to, and for that I'm using the utility called SSH. So I'm just running SSH, the name of the user on that machine. So it happens that I have a user called user, and then at and the location or the name of the host. It will prompt to type the password of that Linux user. And now we are connected. If you recall, in the previous step, when we copied the files, we copied them to a folder called demo. So here are all the files that we copied using the scp command line utility. Remember that the environment file that we have here is the file in which we set the connection to the VMS, the address of the management server, and the credentials of a VMS user, an admin user, that can connect to that machine. There is also these two files, so Docker Compose production and Docker Compose YAML. Remember from what it has been said that one is meant to be used on a production, and thus it only exposes the minimum amount of ports to the outside of the Compose network. And the other one, the Docker Compose YAML, it's a file that we can use in our development setups because it basically exports all of the ports from AI Bridge to the outside of the Docker Compose network. In this case, I'm going to use the Docker Compose YAML one because in future explanations, I'm going to access the AI Bridge from outside of the cluster. But on a production environment, we should run the Docker Compose production file instead. So basically, to run the AI Bridge, we just need to type Docker Compose. In case we need to define or use this file, we should use the -f and pass the name of the file, Docker Compose production. In this case, I'm going to just type Docker Compose, and by default, it will use this file out of the box. We could, in principle, just run the command as Docker Compose up -d for daemon for running in the background. However, there is a catch, which is the OCI images of AI Bridge are hosted on a public ECR repository on AWS, and AWS has a rate limit on public ECR repositories that when you try to download or pull the Docker images in, let's say, in parallel, they might block you because they have a policy to avoid or to have some control on the rates of when downloading to allow one download at a time. So what we do to overcome this limitation is that the Docker Compose command supports this -- parallel option 1. And when we set the parallel option with 1, it means that the AI Bridge or the Docker Compose will pull one Docker image at a time. So if we run this command, The installation will go through each Docker reference on the Docker Compose YAML file and pull the image one by one. Since I've already run this command before, all the Docker images were already downloaded in my local registry. And if I just type Docker images, we can see from here that all the Docker images were downloaded from the public ECR repository. So from that moment, we launch and the average is running. Now, in order to be sure that the average has been properly registered itself in the VMS, we can always check the log and see if the init container has been stopped. To do so, I'm going to use a tool called Lazy Docker. It is mentioned in our official documentation, the steps on how to install it. So I'm just going to run the Lazy Docker utility. And as we can see from here, the average init container has already been stopped. So it exits. That means that the average run register itself in the VMS, and for that matter, the average init container has fulfilled its purpose and it doesn't need to run anymore. So if we go now to the VMS that the average was pointing to, we should have a new entry in the processing server nodes. Let's see here. And we have it here, average, and we have the status connected. That means that the average that we just installed has been able to connect to the VMS. We can see it from the connected status, and that also means that if we go to the register services, there is an entry here for the average. So that it's a sign that the average has been completely or successfully installed, and it has been registered in the VMS. Now that we have seen how to install AI Bridge using Docker Compose, let's see how can we install AI Bridge using Kubernetes. So all of the steps to install AI Bridge on a Kubernetes cluster can be found in our official documentation. So basically, I'm just going to go through all these steps in this installation, but you can get more information from here. So the first thing we are going to do is I'm going to connect to a Linux host in which I have installed Kubernetes engine, and I'm going to deploy AI Bridge. So the first step I'm going to do is to connect to that machine. So for that, I'll be using SSH protocol. So I have a user called user in this machine. And now let's just deploy or see how can we deploy and then install AI Bridge. So now I'll need to provide credentials for that Windows Linux box, and now we are inside. For the purpose of this demo, I'll create a folder called demo Kubernetes. So let me just enter. And inside this folder, we are going to install or pull the OCI Helm package that we host in our public repository on AWS. So in order to do so, I'm just going to use this command to pull the AI Bridge that we want to install. Once this command has been pulled, I'm going to untar the content. And the next step, and if I list the files, you'll see that now we have a folder called AI Bridge. This is the name of the Helm package. And following our documentation steps, the next step we must do is to modify a file called values.yaml. So for that, I'm just going to edit this file and just put this a bit bigger. So the first thing we need to provide is the URL for our management server. So I'll remove the default value and use my management server address instead. All the properties that you can find here are documented in the documentation portal. I'll be installing the Kubernetes cluster in debug mode. That means that all the ports are going to be exposed outside of the Kubernetes cluster. We do not recommend this on production, but for the sake of this video tutorial, I'm going to install it in what we call a debug mode, and therefore exposing the Kubernetes or the AI Bridge ports outside of the network. The next step is to indicate what is the IP address of my Kubernetes cluster. In this case, is a single cluster, so I'll be just setting here the IP address of it. This IP address is also needed for the ingress service, so I'll be just setting it here as well. And the last parameter that it's mandatory is the host name of the Kubernetes of the cluster. So in this case, I'll be using the name of the host that is running Kubernetes. And that's all that we need to modify in this file. So I'm just going to save this content. And now the next step that we must do is to build the dependencies of our Helm chart. By that, we can use Helm dependency build. With this command, we have basically installed the ingress dependency that the AI Bridge has. The next step, and this goes as a recommendation, is to create a namespace, which we are going to call AI Bridge. The idea of namespace is to gather all the resources that are deployed within the AI Bridge. So we are just going to create this namespace. The next step, also documented in the portal, is we need to provide a secret with the credentials of the VMS user that we need that we are going to use for the AI Bridge. So this is what we saw before in the environment file on Docker Compose installation. In Kubernetes, we leverage this information to be stored as a secret on Kubernetes. The next step is to run or to install the AI Bridge. I tend to use the --debug flag because this provides information on what is happening. So once we run the former command, all the Helm chart package is going to be deployed on this machine. This might take a while depending on the host that it's running. And once this command has finished, there shouldn't be any init pod running. You remember from the Compose installation that there is this init container. So in this case, there shouldn't be any pod after the deploy runs successfully of init container type. So let's just wait a bit more. This has finished. If we run the command kubectl get pods with our namespace, as we can see from here, there is no init container pod running. Now let's check on the VMS if the AI Bridge has been registered. So we are going to use the same procedure as in Docker Compose installation. So we logged into management client, and there should be a node from this installation of AI Bridge that we have just done. So here is Milestone AI Bridge cluster, and we can see from here that it's connected. So from this series of steps, we have basically deployed AI Bridge on a Kubernetes cluster. And as mentioned before, for more details, please refer to our Milestone documentation portal. Let's see now how can we customize Milestone AI Bridge installations on both Docker Compose and Helm chart based. First of all, we need to know that when we install AI Bridge, when we install and run AI Bridge for the first time, its default behavior is that it's going to allow access to all of the cameras that are exposed by the VMS. However, when we install AI Bridge, we can always customize and restrict the amount of devices that the AI Bridge can see from the VMS. In order to do so, we made available two properties called zone and scope. The zones property is the one in which we can set the number or the recording servers that the AI Bridge can have access to. And in relation to the scope property is basically if we want to narrow down the cameras that can be retrieved from a certain camera group. Um, both options can be combined, and in that case, the union is the result of the devices that can be obtained. All of the information related to these two properties can also be found in our Milestone documentation portal. However, let's see in this video tutorial where and how can they be modified. So to do so, I'm going to go back to this Docker composed installation of AI Bridge that I have running from before. And on both installations, Compose-based and Docker Compose-based and Kubernetes-based, there is a folder called config. If we enter into this folder, there is one file called register GraphQL. This file is used by the AI Bridge when initializes the first time and register itself on the VMS. And it's in this file that we can add the properties scope and zone. So if I've already modified them and add them here, as you can see, we are using the scope demo and the zone with this recording server ID. So let's see first how can we find the recording server ID. I'm going to log in into management client. And when you are in management client, by pressing the control key and then clicking on the recording server, you will have access to this ID of the recording server. So this is the ID that I've used in the configuration file. And in relation to the camera group, when you go into the cameras node, you will see here that I have this demo folder, this camera group, and I have one camera. So from this moment, when we run and install this AI Bridge, only the cameras or devices from this recording server will be available. And because I'm also adding the scope for demo, only the camera or the cameras that are part of this camera group could be obtained. It's worth to mention that we can pass multiple recording server IDs in case we want to have access to more information. Let's now take the first steps with Milestone AI Bridge and see what can we do with it. The first thing that we are going to explore now is the GraphQL API provided by AI Bridge. As it has been mentioned in other video tutorials, this API can be accessed offline as part of the reference manual that it's located inside of the resources zip file that we provide in the Milestone download page. However, if AI Bridge is running in debug mode, and that means if AI Bridge is installed in such a way that exposes its ports outside of their network being Compose or Helm, then you can explore this API live at your runtime environment. In this case, I have an installation running Compose or a Docker Compose installation of AI Bridge. I'm running Docker Compose YAML, meaning that this is a installation of AI Bridge running in what we call debug mode. And because of that, I can have now access to the GraphQL API at runtime. This API can be found on the AI Bridge location and the port 4000. From here, you can explore a live living API. So it is self-documented based on the code that we are releasing on every single version of AI Bridge. And as part of this API, there is also a plugin, a quite handy plugin called GraphQL From it, you can interact directly with the API and see what the API offers. So for instance, we can start querying some information about the VMS. For instance, well, let's start with the version of AI Bridge. So in this case, this is running version 2.0. Now let's see information about the VMS that this AI Bridge is connected to. So for instance, let's get the URL of the management server and the version of XProtect. In this case, we can see that this is the XProtect that this AI Bridge is connected to, and this is the version of the XProtect running in that machine. Let's see what else we can we find in this with this API. For instance, cameras. Let's see what can we find about cameras. Let's first render their ID and names. So these are the cameras that AI Bridge has been able to sync with the Milestone XProtect system. And let's say, for instance, that I want to explore in depth this camera that has this number as part of the name, or this number is, yeah, it's part of its name. So now we can go back to the cameras and apply a filter as this. So we are filtering by the device name and saying that retrieve any camera that has this value as part of the name. So if we filter again, we only get one result. What else can we find about this camera? Let's explore the video streams. So from the video streams, we can get the, I don't know, the name of the streams, we can get a snapshot from the camera. We can also get the video codec, the resolution from the camera in terms of width and height. So let's see what happens. We get that this is a camera that has one video stream with H.264 codec and this video resolution. Let's see what else can we find inside the video streams. We also have this stream availability property. With it, we have RTSP. So let's see. When we run this query, we get this RTSP feed that we can easily now render or reproduce in a local VLC. And this is a live video coming out of the AI Bridge in RTSP format. Let's see what else can we find. So apart from RTSP, we offer WebRTC and direct streaming protocol. This direct streaming protocol is the gRPC protocol provided for AI Bridge in order to get playback, live video, snapshots as well from cameras. If you want to know more information about this protocol, you can always refer to our official documentation. And in here, the stream availability, we can see the RTSP that we just obtained before, some information about it, and also the direct streaming protocol, which includes the proto file that has the interface that you might need or that you will need in order to implement a client for using this protocol, this gRPC protocol. Let's now check how can we have access to the logs of Milestone AI Bridge. Depending on the installation, the AI Bridge is using, being Docker Compose based or Kubernetes based, the logs might appear on a different location. For Docker Compose based installations, logs can be found at this location, var log AAB, and there will be an independent folder for each one of the containers. Whereas for Kubernetes, in general, we leave the logging for the Kubernetes engine to be handled by it. And therefore, the logs can be found in var log pods directory. Let's explore in the Compose installation what is the expected behavior. So we are in the var log AAB folder. And as you can see, there are one folder per each of the AI Bridge container. So if we decide to sneak a peek into the AI Bridge init container and let's say find or read the last 10 log messages, we can easily do that by exploring as it has been shown. Now that we have seen how to unregister Milestone AI Bridge, let's take a look on how to uninstall Milestone AI Bridge from the system. So basically, as it was mentioned before, when we unregister Milestone AI Bridge, we are detaching the bridge from the VMS. And when we want to truly uninstall Milestone AI Bridge, and by that I mean removing all traces of its artifacts, then we will just follow the standard stopping and removing procedures depending on which type of installation has been running on. So basically, if the user has installed Milestone AI Bridge on a compose environment, then a simply docker compose command down it's enough. And if you have been using, as expected, the Docker Compose production YAML file when installing the AI bridge in the first place, then you will need to pass the -f parameter when calling the Docker Compose down. On the other hand, if you are installing AirBridge on, or if you have installed AirBridge on Kubernetes using our Helm chart package, then the uninstallation process will imply running the Helm on install AI bridge with the namespace that you used when installed. If you have been following our official documentation, that namespace will be called AI bridge. And then the last step will be to remove the namespace from the system. After executing these two commands, then all traces will be removed from the Kubernetes cluster. Thanks for listening in and have a good day.